Let's go.
Hey guys, I'm Nick, and in this tutorial we will be creating this kind of Vellum wrinkles or crumbling inspired by Corp TV, this animation they actually did in Tyflow, and now we will be doing something similar in Houdini. This is a fairly easy tutorial, but there are some tricks that I really wanted to share with you because you know Houdini is all about the details and the parameters that you use and how you use them. So yeah, and also it's springtime, end of the month, so I thought you want to enjoy the weather and not to dig deep into the dark parts of Houdini. And also very important message right now on my Patreon and actually in the Discord. Yesterday we were live and we talked about the things that you guys would like to see more on my Patreon, and turns out that you want me to create and document and explain process of creating commercial 3D animation from the very beginning, pretending that I've just got an email from the client that wants animation for a certain product. And on my Patreon there's a poll. This poll is active till the end of this week, and next week I will begin creating this animation from scratch. I think that we should kind of equally shape the content on Patreon. I mean, my ideas and also your ideas, because here I am sharing things that worked for me in both commercial and non-commercial fields. So yep, there will be a link to that Patreon poll. And also don't forget about our Discord, because all the lives and news, updates, questions, everything that I could give you, all of that is there in our Cozy Place Discord server. I really value every one of you, so if you have any questions or recommendations, don't hesitate to reach out. And thanks so much for your support that allows me to create these tutorials for you. Much more to come in the next few months. Alright, so here we are in Houdini, and what we got here is very simple setup: 3 lights, 2 cameras. One is my kind of preview camera and second one is my main camera. Materials super simple, by the way. So let's start with the geometry, which is also fairly simple. I had my grid, then I used Labs Auto UV and just add a bunch of UVs. You cannot see it, but I think it's because the material. Let me remove it, and maybe the lights also affected at some point. Yeah, now you can see it. So basically Labs Auto UV, I haven't done anything here. And for the grid, here you really want a huge grid, because the geometry gets sucked into the center while forming these wrinkles, so the area is actually decreasing. And for this one I'm using 60 by 60 grid, and rows and columns are set to 250. Let me put back the material just in case I don't forget to do that when we will be rendering. So for the Vellum class, here's the trick. First trick of many here. To make these wrinkles not so small, because we will be using our pop attract, I still want to kind of get a texture of the class, which won't definitely bend to the amount of molecules, right? Still there is some bend resistance for the class. And obviously first thing that we should do is update the bend stiffness. And it's also, with the bend stiffness, it's also tricky, because the more the bigger your grid is, the denser it should be for, let's say, this value of 2 multiplied by 0.1 to look good. For example, if I do the grid done by, let's say, 250 and 250, if I do 100 and 100, I should use less bend stiffness, because we have the distance between the constraints. Distance is more, and it's harder for the class to bend. The only thing I changed here was bend and this edge length scale. So if I visualize our constraints here and go, let's say, now maybe I should visualize the class. Yeah, you see these blue dots. and these are your thickness. You can check this visualized thickness and they will appear here. And this is also the thing that helps us to get these wrinkles and kind of like align them to each other and pack that gloss in the center. Because if I decrease this, you can see that, for example, at 0.1, this is your gloss thickness. So basically, if I bend it, let's say this on this one, it will be really sharp edge there. And by increasing this edge length scale, or actually the thickness, we can achieve much smoother bends. This is really handy when you do multiple close collisions. So, and maybe also if you want to simulate stacks of different thickness, claws of different thickness, you actually can update this to, I don't know, 1.1, just one. So now you see that our claws is not actually a grid, it will be treated as a more like a extruded cube, more like a cube. Let's leave it at 0.4 for now. And now geometry and constraints, 2 nulls. I think that when I was starting out, I was afraid of any tutorials that weren't straightforward, like we drop constraints and then we plug this one here and this one here, and that's our setup. But actually I think that it's better to do all the stuff in the .NET. Houdini right now is pushing that we still can do all the stuff in SOP level. The Pyro source solver, Vellum solver, I think even fluid simulations could be done in SOP level. But as the time goes, I start to think that it's actually a cleaner or more understandable to separate the simulation inside the .NET. So we have less nodes in one, in this case, SOP level. So that's why I drop a geo, I drop a constraint, all of them are nulls, but just, named geo and con. So now we go into the .NET, and here it's all pretty simple, but again, there are a few tricks. So let's zoom out and check what we got here. So you will have this output node. Obviously you would need a Vellum solver, substep set to 2, Vellum object, which is default, and Vellum source that plugs into the right input of the Vellum solver. In the Vellum source, we specify our null geo and our null con, and that's it for the Vellum source. And here in the middle input, which is particle forces, we want to drop a pop drag with a pretty big air resistance. Now it's set to 10. And here's our main node that does everything. So the trick here is to actually understand how pop attract works. So pop attract, and this scenario where the goal is 0, 0, 0, so it's somewhere here, I think. It will, with the default settings, it will forever try to attract every particle, because if I drop another pop attract, it will be better to visualize. So you can see that maximum distance for the hundreds, it will be, for this massive amount of area, it will try to force each particle to land here in the 0, 0, and 0. Force scale is actually the force with which it attracts. Reversal distance is very cool parameter here, and we will be using it a lot. Let's say it's set to 0.5, so everything that is in the range less than 0.5, let's say, let's pretend that 1 UV is 0.5. So this square here, this area is less than 0.5. So everything that is in this area less than 0.5 will not get any force. So basically what's happening here in this area is a reversal force. So it's not sucked, it's actually pushing the geometry out of this area. And peak force distance, let's set it, for example, to 1. So if this is 0.5, this is 1. So this area here, I hope this is 1. So at this area here in the 0.1 and the 1 actually, our force is at its like maximum force scale, and it decreases, and at 0.5 and the 0 it's already a reversal force. I hope that I made it a bit clearer, but here's what we need to do in our pop attract. So a few things here. First of all, I don't want the force scale to be same throughout all the animation. And also, I don't want all the claws to go in that center. So first of all, you can see that what I'm doing here is initially I set the force to be 25. And then every frame of the simulation, I subtract the frame number divided by 30. So here you can see that we start with a 24.96 something. And if we subtract the frame number divided by 30, at the frame 30 we should subtract 1. So if I go to the frame 30, you can see that now our force scale is 24. And if I scroll it, now you see the force scale decreases over time. But that's not the main thing. The main thing here is the reversal distance, which with time gets bigger. So, and that creates the layers of folds around the folds that are being created before. So what I am doing here is, let's say at the frame 50, and the frame 30 actually, reversal distance is set to 0.3, which is in this large grid something very tiny here. But if we simulate till the frame 90, our reversal distance is 0.9. So what it means that, don't judge by this ugly thing here. It means that these in the center of the grid, these wrinkles are not affected anymore, because otherwise it might produce some sort of overlapping issues and all that stuff. And now basically, so you can see that this part here is not actually sucked into the middle anymore. It just compresses because of the other parts of this grid are attracted to the center. And this is a really cool way how you can create sort of a follow for the any sort of effect, which is based on the puppet tract, of course. Drag also comes handy here and makes it just a bit more smoother, the effect, not the geometry. But yeah, here is this part. And also I don't have any gravity here, I think. Yeah, I don't use any gravity, but I added this ground plane here just to make sure that all of our wrinkles are kinda going Y up. I don't want them to go below the actual ground plane. So now we drop a DOP import node, which is this one. And we drag and drop our DOPNet here and object mask, click this drop down and select Vellum object. You should delete, there will be this asterisk, we don't need that, we just need Vellum object. And import style set to fetch unpacked geometry from DOP network. So then I cached 210 frames and it looks like this. So here is basically a good example that you really can see that the center part is basically static. It's not moving anywhere and it's all just around the wrinkles that were there before. So it's just like more like a compression, not attraction force. Now this will be resource heavy and you drop a Vellum post-process node after the file cache and it makes everything much smoother. So what I did here is added a bit of spatial blur, subdivision set to Catmull Clark. Oh, nope, to Catmull Clark. Subdivision depths 1. You can go with 2, but it will be even more heavy and it will take much longer time to actually process each frame. Here is the subdivision depth set to 2, and I honestly don't see much difference in knowing how much time it takes to subdivide each frame. I would say let's go with a subdivision depth set to 1. And also a pretty important thing that you want to do is check this extrude by thickness, because here I have it checked and here how it looks without it. So I definitely prefer this option over non-extruded. And then I wanted to add a bit of slow motion, so I drop a retime, and I don't want these first frames when it just starts. I want it to be already something in the center of the frame. So output frame range is set to 190 frames and input frame range is 60 till 180, because after 180 it actually it went out of frame. I saw these blank spaces here. I could go with a bigger grid, but I thought it's all right. And speed is set to 0.6. So if I bypass this Vellum post process just for the sake of preview speed, here's how my animation looks. Despite of this being pretty easy tutorial, I still think that it's really crucial to know how to manipulate different parameters, because as you can see here, manipulating just a few parameters gives us completely different result in comparison if we left Puppet Track at default. Let's enable Vellum post-process back and maybe scrub to the last frame. Now let me show you the lights and material setup. So let's enable the camera, our main camera. So it's this vertical camera with the focal length set to 120. Also, I played a bit with Redshift photographic exposure and did a bit of color correction in Redshift itself. Also, I have 3 lights. One light is from here, the second light is here, and the third light is just for kind of like smoothing the shadows. So it's just this big soft light. For the materials, it's super simple. Also, I created this texture, which is this diff texture, and applied to the diffuse color in my Redshift material. Reflection roughness set to 0.55. And yeah, I think that's it. Let's fire up render and check how it looks. And here it is. Alright guys, I think that's it for today, and I really hope that you learned something new. Puppet Track is super fun node and you can do a bunch of really cool stuff with it. Just be aware that the parameters might be tricky and manipulating them will bring you some really unexpected, in a cool way, unexpected results. Huge thanks to all of you for supporting me. Much more to come next month, and I will be back really soon. Bye!